Can we continue?
Yes, teacher.
Okay, the line
Yes,
MN,
teacher.
the line MN at a known angle of incidence. Angle of what? Angle of incidence. I, angle of incidence I is drawn. Is it drawn? Like you can see that line from there. The next step after that, two optical pins. Now we fix these two pins here, this one here, P1 and P2. We fix pin along the line after measuring this angle I, after measuring angle of incidence. So now you fix two pins there. So two optical pins, P1 and P what? And P2 are fixed on the line, fixed on the line, on which line? On which line, members? Line M what? MN. I'm trying to break it so that it look easier so that you can follow it very well. After that, the glass block, the procedures are many, but the glass block is placed back. The glass block is placed back. The glass block is placed back onto a white sheet of paper. Onto a white sheet of paper. Onto a white sheet of paper through its outline. Through its what? Outlines. So after measuring this angle here, after measuring this angle and you have fixed the pins P1 and P2, now you bring the glass block. You fix it back onto it what? Outline A, B, C, what? D. Now, because why do we do that? Now we want to study the effect of refraction now from there. We want to study the effect of refraction from that instance. So a glass block is placed back onto a white sheet of paper through its outlines, That next, now you start viewing. So while viewing or looking through face CD, of the glass block, of the glass block, comma, two other optical pins, P3 and what? P3 and P4 are stacked or are fixed, stacked or fixed, stacked or fixed, stacked or fixed, such that they appear, they are in a straight, they're in a straight what? They're in a straight what, members? They're in a straight what? They're in a straight line with the images, P1 and P what? With images of P1 and P1 and P2. After that, members, the glass block, I want to expand it so that it looks very simple and simplified. After that, the glass block and optical pins, P1, P2, P3, and P4, are removed. Are removed. Because now we have fixed these two pins. We fix them in such because of refraction, it will appear. You find that this line here, it will appear to be Along this line here, members. Are you seeing this along this line, members? Are you seeing this line here? Members, are you seeing this? Are you seeing this line here I've made in dotted line? The images of P1 and P2 will appear to be in this line here. Will appear to be in this line here. Okay? Okay? Will appear so that you fix P3 and P4 in such a way that they appear to be in a straight line with these images of P1 and P1 and P2. Are we together, members? Are we together? Are we together? Yes. So that's how it will look like. I will show you a video on that. I will show you a video on that. So after removing that now, we draw a line. So a line through the max, a line through the max of P3 and P4 is drawn. Is drawn to meet side CD, at which point? At what? At point. So we draw this one, the max here, to meet this line here at what? At X. So at X and point X is joined to point what? To point N. So after drawing this line, members, after drawing this line here, you join X now to N. Why do we join that? Because now I want to measure this angle here. And you should know how we place the protractor. We should know how to place the protractor there. We shall see that one in a video. How to measure that angle, okay? Okay? Yes. After that, what do we do now? After drawing this line here, we measure the angle, not so? We measure the what? The angle. So the angle of refraction, R, in glass is measured. Is what? Is measured and what? And recorded. Is measured and recorded. After that, we repeat these procedures. We repeat all these procedures. The above procedures are repeated. The above procedures are repeated for different values of angle of incidence. Are repeated for different values of angle of what? Incidence I. Are repeated for different values of angle of incidence I. So whenever you measure angle of incidence, you must measure the angle of what? Refraction. Then the results are tabulated. The results are tabulated in a suitable table. The results are tabulated in a suitable table, including values of sin I and sin what? And sin R. Why? Because for us to determine refractive index, we need sin I and sin what? R. Okay? Are we together, members? Are we together?
Yes, teacher.
Yes. Then after that, because the values are many, we have to plot a graph. So a graph of, so sin is a ratio of sin I, which means is going to be a graph of sin I against sin R is plotted. A graph of sine I against sine R is plotted. Is plotted. After that, the slope S of the graph is determined. The slope S of the graph is determined. Is what? Determined. Are we together? Are we together, members? Are we together?
Yes. Yes.
Okay, I want to turn around. I want to turn now. Good. So, like I always say that you give the procedures and then you must conclude. So now after getting the slope, what do you think the slope will give us, members? Because the slope will be sine I over sine R, because slope is the same as gradient. Slope is the same as what? Gradient. Gradient is the same as slope. So we can now say the refractive index. The refractive what? Index Ng, which is the refractive index of glass, of the material, of the glass block, is obtained. Is what? Is obtained from the expression. Is obtained from the expression that is the slope is equals to the refractive index. The slope will be equals to the refractive index. The slope will be equals to the refractive index. Are you together? Are you together, members?
Yes, teacher.
Yes. So let's look at the sample of table of results. Sample of table of results. So this is how our table will appear. Take note of that, members. Take note of that. This is how our table will appear. This is how our table should appear when performing this experiment in the lab. So the first one, I will have sine I, which is in degrees. So you make the degrees to be raised a bit. Then we shall also measure the angle of refraction, which is also in the degrees. Then we shall have sine I. It has no unit. Then sine what? Sine R. Sine what? R. Okay. That's the sample of the table. That's how our table should be. Then the graph. A graph of sine I against sine R. Our graph will appear like this. This is how our graph should appear. This is how our graph should appear. Sorry. This is how our graph should appear. So in the vertical axis, we shall have sine I. Then horizontal axis, we shall have sine what? R. Sine R. Then the graph will be a straight line graph. A straight line graph like that. Okay. Members, have you seen that?
Yes, teacher.
Yes. So the procedures seem to be long, but if you know the details, if you know the details, so let me say maybe we are starting maybe 10, 20, 30, 40, 50. Okay? Okay? Members?
Yes.
This is it. This is a sample, but I want us to go beyond the, if we are using from the theory, what is the refractive index of a glass from the theory? What is the refractive index of a glass? Is 1 point. We know that refractive index of a glass is what? 1.5. 1.5 what? 1.52. So we are going to generate these values theoretically. We are going to generate these values theoretically, okay? Right together. We know that refractive index is equals to sine I divided by sine what? Sine what? Sine what? For glass block, refractive index is 1.52. So from here, I've already given you the values of the refract. I've given you the angle of incidence. Now I want us to use theoretically, okay? If the angle of incidence is 10, what do you expect the angle of refraction to be? Should it be more than 10 or less than 10? Members, remember is moving from air to glass. From air to glass. What do you expect the angle of refraction to be? Should it be more than 10 or less than 10?
Less than 10.
Less than 10. Good. Less than 10. Let's prove it. Let's prove it theoretically by calculations. By what? By what? By calculations. So we shall have our refractive. Now I will take refractive index to be 1.52. I want to find the angle. I want to prove that it must be less than 10. So I will say 1.52 is equals to sine I is what? I is what? I is 10 degrees. 10 degrees divided by sine R. Divided by sine R. So this is the same as over 1. You cross multiply. You find out you shall have 1.52 sine R equals to sine of 10. Equals to sine of 10. So divide all through by 1.52. Divide all through by 1.52. So this and this will cancel out. So you find that sine R is equals to sine of 10 degrees, sorry. Sine of 10 degrees divided by 1.52. Now, if you want to find this one here, we get what we call the sine inverse. We get what we call what, members? We call it the sine what? The sine inverse, which means R is equals to sine inverse, which we write like that, over sine of 10 degrees divided by 1.52. Divided by 1.52. So R will be equals to, this is how you press your calculator. This is how you press your calculator. So first reset, and make sure that your calculator is in degrees. Make sure that here is indicating D, okay?
Yes.
So you press sine of 10 like that, divide by 1.52. Divide by 1.5 what? 2. What do you get? We get
0.114.
This one, now to get the sine inverse, to press sine, you press sine inverse, you press shift. You press what? Shift and sine. Shift, sine. I think that of the answer, what do you get? The answer is what?
6.5599.
6.5599 degrees. Remember, if you are using a protractor gives to how many decimal places, members? A protractor give us a what? A whole number, not so. A protractor give us a what? A whole number. So when you round this one to a whole number, what do you get?
7 degrees.
7 degrees. So which means if you are doing it practically, which means the angle, the answer you must get here must be what? Must be?
7.
Must be 7. I think that.
Yes.
What about if it's 20? What about if it's 20? If I is 20? Which means now we shall have sine of 20 divided by 1.5 what? 2, because this one is constant. Refractive index of a glass is constant, okay? It remains 1.52 throughout, okay? Are you together?
Yes. Yes,
Mhm.
teacher.
We get that. Shift, sine of that. So the answer is what? We get what? You get what? 13.
That
So which means here is supposed to be? Here is supposed to be 13.
13.
What about if it's 30? So we shall have sine of 30. Sine of 30 divided by 1.52. Shift that. What are we supposed to get? We're supposed to get 19, not so? So which means here is supposed to be 19.
19.
If it is 40, so if it is 40, we shall have sine of 40 divided by 1.52. That. Shift. What are we supposed to get? We are supposed to get 20. 25. 25. If it's 50, what are we supposed to get? Sine of 50 divided by 1.52. Shift that. We are supposed to get what? 30 what? 30 degrees. I think that, members. I think that.
Yes, teacher. Yes.
Now let's complete our table. I want to get sine of I, which means sine of 10. When you are recording sine I and sine R, they're recorded to how many decimal places, members? They're recorded to how many decimal places?
3 decimal places.
3. So sine of 10, what do we get? Sine of 10. Sine of 10. We shall get 0 point. Going to be 0.1.
7.
7 what? 7 what? 4. Not so? When you round off. What about sine of 20? Sine of 20 you get 0.3.
0.342.
What about sine of 30? You get 0.5.
0.5.
But we said it must be recorded to how many decimal places?
3 decimal places.
So what do? You add how many zeros?
You add 0, 0.
You add 2 zeros, right?
Yes.
So what about sine of 40? Sine of 40 is 0.6. 4 what?
3.
43. What about sine of 50? You get 0.766. Right? I think that, members. I think that. Members, have you seen that?
Yes, teacher.
And when you are doing your work in the table, the decimal point must be in one line. I think how mine is. The decimal point must be in one line. Your work must be organized. Your work must be what? Organized.
Organized.
So let's go ahead and find sine of R. Sine of R. So sine of 7. Sine of 7. What do we get? 0.122. Not so?
Yes.
Sine of 13. What do you get? Sine of 13. We shall have 0.222. What? 22 what? 225. What about sine of 19? Sine of 19. We shall have 0.3226. Not so?
Yes.
Then sine of 25. Sine of 25. We shall have 0.4.
0.423.
3 decimal places, please. Don't forget that. 3 decimal places. Sine of 30. We get 0.5000. Now, if this was your experimental values, okay, remember we said refractive index is equals to sine I divided by sine what? Sine what? R. So I will just pick any 2 set of values. Which value should we pick? I can pick this one here. I can pick 50 and what? 50 and what?
50.
So what is we have? So which means I'll say sine of 50 divide 50 degrees divide by sine of 30 what? 30 degrees. Not so. The answer we must get must be what? What's the answer we should get, members? The answer we should get must be 1.5 what? Must be 1.552. So what is sine of 50? Sine of 50 we add 0.766 divided by 0.500. So when you divide that, what do you get? 0.766 divided by 0.500. I think that.
Yes, teacher.
Yes.
We have got 1.532. Why are we getting this? Because of the effect of rounding off. The effect of what? Rounding off. Remember here we were rounding off, not so? Here we were what? Rounding off. To how many decimal places? To how many decimal places? Two?
Three
three.
decimal places.
Members, have you understood that? Have you understood that?
Yes, teacher.
Yes,
Now,
teacher.
that is the theory. That is the what? The theory. Now,
Yeah.
let's see, how do we perform? How do we realize these values are the 7, the 13, the 19, the 25, and the 30? So let me take you to YouTube here. Let me take you to YouTube. I want to get a clear one for you, a clear one. Good. Welcome to Tobacco University. Here we're going to be looking at members. Yes, members. Teacher. I want you to follow this video very well. I want you to see the effect. We are talking about the effect of refraction and how we determine the refractive index of a material, okay?
Okay.
Yes. Is looking at when light travels from one medium to another, its changes relative to the density of the medium, which is observed bends traveling. The speed of light divided in a vacuum c is always the same. But when light moves from one medium and travels more slowly as it goes to another medium, it is constantly being absorbed and re-emitted by the added material. Now, the ratio of the speed of light in a vacuum to the speed of light in another substance is defined as the index of refraction or refractive index. It's represented in equations as n for that substance. Notice this actually looks like. Well, up here we notice that when light travels from one change speed. What's kind of a neat experiment here? If you have a glass with a piece of paper behind. Members, are we together? Members, are you following?
Yes, teacher.
This one is just repeating the theory that we have looked at. Let me give you another one. I want the one which is straight to the experiment. I want the one which is giving us straight to the experiment, which is this one here. Good. My job is to make colleges because students have a lot. Members,
Yes, teacher.
are you following the procedures? Are you following the procedures? Yes,
Yes.
yes, be following, be following.
हाँ बोलो बोलो भाई
Yes, members,
Teacher.
you have seen how they perform it, eh?
Yes.
Yes, so we can't finish the video now because we are running out of time. We are running out of time, but I believe you have picked the concept there, how to perform the experiment, right? Members,
Yes.
have you picked some concept how to perform the experiment? So that's what I expect from you in that experiment. Good. All right. So members, the same procedures here, the same procedures here, the same procedures, right? Not. The same experiment, the same experiment can be used to verify. Tomorrow they may ask you to verify Snell's law. The same experiment can be used to verify the Snell's what? The Snell's law.
Nice. Look.
They can also, the same experiment can also be used to demonstrate, to demonstrate the principle, of what? Of reversibility of light.
Right.
The same procedures, the procedure will not change. The only thing that will change is the conclusion. Is the what? Is the conclusion, how you conclude. On how to demonstrate the principle of reversibility of light. The same experiment can also be used to verify Snell's what? Snell's law. The same experiment can also be used to verify the laws, the laws of refraction of light. To verify the law of refraction of what? Of light.
Refraction of light.
Are you together, members?
Yes, teacher.
So in the same experiment we have done, how many possible questions can be set from there? How many? 4. There are 4 possible questions, right?
Yes.
The first one is determine the refractive index, not so?
Yes.
The second can be used to verify the Snell's.
Snail's law.
The second can be used to demonstrate the principle of reversibility of. Then the fourth one can be used to verify the laws of refraction of.
Light.
The procedures are the same, members. The procedures are what? Are the same.
Procedures are the same.
The only thing that will change is the conclusion. The what? The what?
Conclusion.
The conclusion. Now, what if it's for Snell's law? Are you going to conclude for the Snell's law? Are you going to conclude? Because Snell's law is talk about what? The ratio of what? The ratio of what? It states that the ratio of sine of angle of incidence is to sine of what? Angle of refraction is always constant, right? Right? I think that, members, you conclude like that. You conclude like that. You said, since the sine of angle of incidence is equals to, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, hence Snell's law verified. Hence Snell's law verified. Then when it comes to the principle of reversibility of light, like we were discussing from here. So here I'm only interested in the ray diagram. So you follow the steps, you draw the ray, it would appear like this. Then you have now assume remember here if we reverse it from here, which means if you bring it this one, you are seeing from this side, you will see the light will follow still the same path. It will still follow the same what? You still follow the same
path.
The same path, which means you have verified the what? The principle of reversibility of light.
Of light.
Then to answer the third one, verifies the law of refraction of light, which means here you are combining the two things. You must remember the law of refraction of light. The first one, let's talk about the incident ray, the refracted ray, and the normal line at the point of incidence all lie on the same plane. Don't you see this one? Are they not on the same plane? Are they not all on the same plane, members? Are they not on the same plane? They're all on the same plane. They're on the same plane. Then the second one, now you state the Snell's law. You state the Snell's what? The Snell's law. As simple as
law.
As simple as
that.
As simple as that. Are we together, members? Are we together?
Yes, teacher.
So next time we meet, we shall now do calculation on this formula. We shall do what? Calculations. We shall do what?
Calculations.
Subheading. Calculations. That's right there, calculations. Okay?
Yes.
Okay, members, bye. Our time is